So factoring is simply distributive property backwards. It's where you have the answer and you want the distributive property problem, okay? But it's not just that, right? If we were to take any regular number, like let me move this out of the way. If I were to take like the number, give me a number, any number. 12. And I tell you, do a factor tree with 12. Now the word factor's in there, right? So when I say factor tree, what does that mean? What do you need to do with 12? You need to factor it, right? Now, what does that involve? The multiplication, right? So you break it down and you go like 3 times 4, and then you could continue breaking down the 4 to 2 times 2. So factoring is not just a reverse distributive property, but it's really like taking a value and then creating multiplication out of it, right? But in this case, since we were distributing a monomial into a polynomial, the very first method of factoring that we learned was pulling out the GCF, which is simply distributive property backwards. Anyway, number 2, what methods of factoring have we learned so far? Okay, so the basic factoring, that is method 1, pulling out the GCF. Factor out the GCF. So what's important about that method? You have to make sure that there's something in common in every single term. If there's a 3-term polynomial, you have to have it in common in all 3 terms. If it's a 4-term or 5-term, it has to be in all 5 terms. So every single term inside a polynomial has to have that GCF in order for you to pull it out. What was the other method? Let me get this out of the way. The other one is grouping. I don't have space. Method 2, factoring by grouping. And that one's a little bit more entertaining. It's 3 steps. Step 1 is to separate them into 2 groups. Just leave some space between the first 2 and the second 2 terms. And then after that, you factor from the first group, you factor from the second group. And then your final step is to take a step back and factor what you see in common in both groups, which is usually a binomial that's in common in both groups. Anyway, let's make some space here for questions 3 and 4. So I'm going to move 4 to the side over here. I'll bring it back right now when we're ready for it. On number 3, what method are we going to use? Are we going to do factoring by grouping right here? No. What are we going to do? We're going to do factoring out the GCF. The GCF, right? So the greatest common factor. So if you look at those 3 terms, what is the greatest common factor? Okay, there's definitely a 2 in every single term. There's 10, 2, and 14. So I could definitely pull out the multiple of 2. But is that the greatest amount? Is that the greatest thing that I could pull out? Or is there something else that I could pull out? Also an X. And a Y. Okay, so let's pull out that 2 and an X and a Y. So this is the setup when you're factoring out the GCF. You first have to identify the GCF by looking at your 3 terms or all of your terms, and you got to find out what's the greatest amount that you could pull out. So we could pull out a 2 and an X and a Y. You do the parentheses, and now here's where you got to think backwards on distributive property, right? Like if you were to distribute 2xy times something, what would it have to be in order for it to be a x to the third y to 10x to the third y to the third? What would it have to be, that first term? 5x squared y squared, right? How about for the middle term? If I were to take 2xy times what will give us that negative 2xy squared? Just a negative y. You can put a negative 1y if you want. But, I mean, that makes sense. If you multiply 2xy times negative y, that'll be a negative 2xy squared. And the last one, 2xy times what would give us a positive 14xy? 7. Just 7, right? And we're going to put positive 7. And that's factoring. That's factoring out the GCF. What is the GCF? This guy out here. Everybody cool with factoring out the GCF? All right. Let's move on to question 4. This is obviously factoring by grouping. Okay, so step 1 on factoring by grouping is simply making space making them into two groups. Right there it looks like it's a polynomial, 4 terms. I'm going to split the first 2 terms and the second 2 terms. I want to create 2 groups. So I just rewrite it with some space between them. Now let's look at the first group. I'm going to factor something out of this first group. Even if I can't factor, I'm going to try to factor out a 1. All right, I will factor out a 1, but I could factor something. What's in common? An x. So ladies and gentlemen, if I pull out that x, what would be left? An x minus 2. Now let's take a look at the second group. What's in common right there? What's in common in the second group? You have a 3x minus 6. What could you actually pull out? A 3, a positive 3. And if you do pull out that positive 3, what's going to be left on the inside? X minus 2. Now that is a really good thing. Why is that? Because step 3 is to take a step back and look at your first group, look at your second group, and take out what's in common, which is the binomial x minus 2. Now, if you don't have this same binomial, if it's not identical, right here it says x minus 2, right here it says x minus 2. They're identical, you could pull them out, right? But if they're not identical, you have problems. You can't continue. Unless it's something simple where you could just change the signs. But anyways, right here, they are identical. So I want to take this x minus 2 and this x minus 2 and pull it out here to the front. And of course, I want to write some exaggerated parentheses to show what I have left over. If I pull this out, there's only going to be an x left over. So there's my x. If I pull out the x minus 2 from here, then I'm only going to have a 3 plus 3 left over. So again, I'm exaggerating these parentheses. I'm leaving this blank spot right here so you could visually see that we factored out that binomial in both groups, the x minus 2. So now that x minus 2 is out in the front. Of course, when you write your answer, you're just going to write it with the correct size parentheses, x minus 2 times x plus 3. And if you were to distribute this, x times x, x times 3, negative 2 times x, negative 2 times 3, combine like terms, you'd end up with this original problem. Actually no, you don't combine like terms. They didn't do that in the original. Anyhow, but that's how you factor. That's reverse distributed property. Let's move on to the final section on yesterday's lesson, which was zero product property. So let's go to the handout that we had yesterday. And we went through the whole handout. We factored. We pulled out the GCF. We talked about some that were not factorable. We did factoring by grouping. And you know what? We did have a typo on this question at the bottom. It needed a b squared right there. So as a matter of fact, even though I explained it on yesterday's video, I'm going to explain it again right now. Because this one's really interesting. It's like the most challenging type of problem there is when it comes to factoring by grouping. Let's go through the process. What's step 1? Separate. And once again, make sure that you have that b squared. I think there was a typo on your worksheet. It didn't have. It just said plus 20. You can't do it unless it's a b squared right there. Anyhow, we separated. Step 2 is the factor from the first group, factor from the second group. So on the first group, I'm going to pull out the GCF. And what's the GCF on the first group? 3 and an a, 3a. There's definitely a multiple of 3 with the 12 and a multiple of 3 with the negative 15. And there's also an a here and an a there. So we could pull out the GCF 3a. Now, what belongs inside of the parentheses? 4a minus 5b. Let's take a look at the second group. What could we pull out of the second group? What's the GCF? 4b. Okay. Now, if I do pull out a 4b, what do I end up with inside of the parentheses? Negative 4a plus 5b. Now, third step is to take a step back and pull out the common binomial. But the problem is this binomial is not identical to that binomial. Does that make sense right here? The binomial is not the same, so you can't pull it out. Now, sometimes you're going to get completely different binomials like 4a plus 7 and 4a minus 13, and there's nothing you could do about it. But right here we see that it's the same binomial. It's just that it has opposite signs. Right here you have a positive 4 and a negative 5. Right here you have a negative 4 and a positive 5. So all you have to do is change the signs by factoring out a negative. In other words, let me go back. Instead of pulling out a 4b, if I were to pull out a negative 4b, then what would I have on the inside of the parentheses? That would be a positive 4a now, and that's what we wanted. And it would also be a what? Negative 5b, and that's exactly what we wanted. Now the binomials really are identical. Does that make sense? Yeah. I mean, it's a huge difference. Just by pulling out this negative, it changes those signs, and now you do end up with a common binomial. Now you could do step 3, where you take a step back, and you pull out the binomial that's in common. So I'm going to take this 4a minus 5b and this 4a minus 5b, and I'm going to pull them out, write it out here in the front. And what would be left on the inside of the parentheses if I do pull out that binomial? 3a minus 4b. And that's it. That's your answer. So now that we're on this worksheet, let's go to this final portion where it says zero product property. Actually, before this, let me just ask you something. 3 times a number equals 0. What is that number?
0.
0, right? Could it be anything else? Could it be any other number? No. It's as simple as that, guys. When you have 3 times a number and the answer is 0, well, this number has to be 0. That's the only way you're going to get 0 as an answer. Okay? And that truth is very interesting because instead of just looking at it as like 3x equals 0, where we know x has to be equal 0 right there, you could also say, maybe instead of 3 times x equals 0, you could have x times y equals 0. Now, if you do have a number times another number and it equals 0, then this number could be 0, or the other number could be 0, or both could be 0, right? So when you solve an equation, you're trying to find the possible answers that'll make it a true statement. So what do we know about this? We know that x could be 0, and also y could be 0. So you get 2 answers right there. So now that we understand that, even if I had x times y times z equals 0, then you could say, oh, x could be 0, y could be 0, z could be 0, right? And this is all actually the zero product property. So jumping back to our handout, that's what it explains right here. If a number times another number is 0, then that first number could be 0 and the second number could also be 0. So whenever you're multiplying 2 items and you get 0, you know that that first item could be 0 or the second item could be 0. Very easy to understand zero product property. So why is the zero product property important? Because it helps us solve quadratic equations. Now, if we take a look at number 1, this is an equation. Now this equation, the left side of the equal sign, it has a binomial times a binomial. In other words, it has a quadratic trinomial in factored form. Now, back in semester 1, when we first started solving equations, we said step 1 on solving an equation is to simplify, right? So some of us might be thinking, let's distribute. Let's go x times 2x, but let's not do that. You know why? Because we know zero product property. We know that if you have something times something and it equals 0, we know that that first something could be 0, and also the second something could be 0. Does that make sense? So, number 1, it looks like a complicated multi-step equation, but if you know zero product property, you're able to take these binomials and split them and set them each equal to 0, and it becomes 2 simple equations that we could solve, with a couple of steps. So, on the left side, solve it by going plus 9, x equals 9. That's your answer. On the right, simple equation, minus 1, you're going to end up with 2x equals 0, take away 1 is negative 1. What's the final step right there? Divide by 2, and yes, x equals negative 1/2. So we have two answers for number 1, x equals 9 and x equals negative 1/2. This is why zero product property is so important. Because when you do have something times something and it equals 0, you could take that complicated looking equation and split them into two simple equations. And it doesn't have to be a binomial times a binomial. Check out number 3. Going out of order. I have something times something equals 0. So I could take this first something, set it equal to 0, take the second something and set it equal to 0. So x could equal 0, and also the x plus 12 could equal 0. So the zero product property allows us to split them and create two simple equations and then solve those two simple equations. This one's so simple that it's already solved for us. X equals 0, that's an answer. And the other one, minus 12, x equals negative 12 is the other answer. And that's it. Those are the two answers that work for number 3. What do you think? Easy. It's easy. Okay, so let's go to number 2. I'm sorry. Number 2 over here. Could I apply zero product property right now? Do I have something times something equals 0? No, I do not. I technically have something plus something, but that doesn't apply with the zero product property. Actually, product means multiply. So I need to have something times something. So what we want to do is factor, right? Like if I tell you factor the number 10, you could say 10 is really 5 times 2, right? So you could create a multiplication problem. So right here, I'm going to factor. And the methods we know of factoring is by grouping. We're obviously not going to do by grouping or factoring out the GCF. What is the GCF of the left side of this equation? I'm only looking at this side. What's the GCF right there? X. So what's left on the inside? X plus 4. And remember, it's still equal to 0. So all I did was factor the left side. But now, by factoring, I really do have something times something equals 0. So now I could actually use the zero product property and split them. So this x is going to be x equals 0. This x plus 4 is going to be x plus 4 equals 0. And I solved both of them. This one is so easy, it's already done for us, x equals 0. And this other one, subtract 4, x equals negative 4. So you have those two answers for number 2. So zero product property, it looks like it's totally random, something new, right? Where, something times something equals 0. But the reason why we're doing zero product property right now is because we are learning how to factor. And when you factor, you end up with multiplication, and then you could apply the zero product property. So let's take a look at our homework now. So if you don't know about this zero product property, you cannot do questions 19 through 26. So some of them are super easy because it's already set up. It's already in factored form. Like look at number 19. That's already ready to apply the zero product property. So all you're going to do is rewrite it. You're going to split them. So I'm going to rewrite it as x equals 0 and as x minus 8 equals 0. And then I solve both of them. This is already solved. And this one over here becomes a plus 8 and a plus 8. So x equals 8. And if you look at the back of your worksheet, the answer to number 19 is 0 and 8. It's two answers. So 19 is easy. Is 20 easy? Is 20 easy? Yeah. What's the answer to 20? Or what are the answers to 20? B equals 0 and B equals negative 12. How about the answer to 21? M equals 3 and M equals negative 5. Okay, we're doing this work in our head, but even though you could do it in your head, I want you to show your work. So what do I mean by show your work? Let's use the zero product property. Take this guy, write it over here, set it equal to 0. Take that guy, write it over here, set it equal to 0. So M minus 3 equals 0. M plus 5 equals 0. Show your work. Plus 3, M equals 3. There's one answer. minus 5, minus 5, m equals negative 5. That's your other answer. So these are very simple. 22, is that easy? Yeah, you just split them, set them each equal to 0. Now down here, 23, 24, 25, those are a little bit more interesting. Okay? Because you have to get that multiplication first, which means you have to be able to first set it equal to 0 and then factor it so you could split it and solve. So on number 25, even if you were in semester 1, you would be thinking, okay, I want to get a by itself on one side. Well, I have an a here and an a there. And you would subtract 6a, this would cancel, and you would have equal to 0. But on the left side, you can't do 3a squared take away 6a. They're not like terms. So you'd have to rewrite it. 3a squared take away 6a. And now at this point, you need to know how to factor the GCF from the left side of the equation. So what's in common in both terms? In the 3a squared and the minus 6a, what's in common? 2, well, not 2. 3a, right? So you have a 3a squared here, you have a 6a here. There's the multiple of 3, so I'm going to pull out that multiple of 3 and also the a that's in both terms. So if I do pull out a 3a, what's going to be left on the inside? It's going to be a minus 2, perfect. So now we truly do have something times something equals 0. And now we could take this something and split them and set them each equal to 0. And we have those two simple equations. All we have to do is solve them. On the left equation, all you have to do is divide by 3, and you still get a equals 0. That's an answer. On the other one, plus 2, a equals 2. That's another answer. And that's it. We're done. Cool? Okay, so if you have not finished this entire worksheet, which I know we haven't done all these, finish it right now in class. And you should have everything complete. We're spending 2 days on one single worksheet. And I've done some of them for you, so please let's complete this before leaving today.